Hello, everyone. Welcome to the next episode of the Hewlett-Packard's Lab podcast from research to reality. Today, we will be covering the topic of digital twins for data centers. I have a great honor and pleasure for the third time to host on this podcast, Soumyendu Sarkar.
Hi, Dejan.
It
was a pleasure.
Pleasure is mutual. So we had Soumyendu for the second time on this side of the camera. We had him once on the other side, together with the crew when he was helping. Last time, it was the COVID time, so we recorded in front of my house.
Yes.
So Soumyendu, you're already professional here. Can you introduce yourself a little bit, even though you were here, just for those who missed our first episodes?
Yeah. So I started my career in speech recognition, and then the AI winter came in, and I chickened out, and I moved to General Electric, where we are building the first digital relay for protecting the power grid. It was exciting, but then I moved to Bell Labs, where I actually learned engineering from some of the great people and learned to be a technologist down the way. I was working on a variety of topics from modems to media gateway for telecom gateways, and then also like video and some of the cool stuff, including speech, which was my passion during those times. And then I moved to Intel, where I was working on computer vision and imaging. The product scaled to 100 million plus customers. And then I was doing the startup, as many people do, in the Silicon Valley for a couple of years on machine learning. And then about 7 years back, I joined Hewlett-Packard Labs, actually Hewlett-Packard Enterprise. And then I was fortunate enough to work with smart people like you in Hewlett-Packard Labs. And there I do a variety of different things on AI. My passion is sustainability, but we also work on some of the trustworthiness of AI.
Now that we are in the deep, hot summer of AI, what does it mean to you to be back in this area?
It's fascinating. And the way I see it is, how do I bring in the human perception in machines and then scale them up to have bigger brains doing similar stuff? It is a challenging world, but also it's an extremely rewarding world. As to how we carry our perceptions to machines to solve problems better. And two of the topics that I'm very passionate about is sustainability, of which the data center digital twin is a big part of it. But I also work on things like applying machine learning to nuclear fusion to bring in the energy of the sun and stars to Earth as a sustainable clean energy. And also some of the other topics like bringing machine learning to wave energy converters. How do we harness the power of the ocean waves? Again, another form of clean energy. But on the other side, what also concerns me is with this power comes responsibility, right? How do we make AI trustworthy and responsible? So we have been doing some work in that area, and I'm also the principal investigator for HP for the Artificial Intelligence Safety Consortium under the National Institute of Science and Technology from the US Department of Commerce. So those are two of the things that really invigorates me, and working with smart people like you.
Thank you. The respect is mutual. You covered and described very eloquently all the areas that you work on, but I know that you also have a large team and many more students and partners inside, outside of the labs. So what are your roles and responsibilities in this ecosystem of AI for sustainability in general? And then we'll come back to digital twins for data centers.
Yeah, I think early on from my mentors in Bell Labs, what I learned was I need to be a good individual contributor, working on some of the key concepts. But where I can contribute much better is to scale this effort. And when I meet so many smart people in Hewlett-Packard Labs, some of whom are in my team, some of whom are outside my team, and also I see the world to be playground for collaborators, because enrichment from people outside our fields does the magic. Just to give you an example, when we're working for the wave energy converters with Carnegie Clean Energy, We learned so much from Carnegie. And that collaboration between the domain experts and the AI experts does the magic. And that is the key recipe for a success. And of late, we are fortunate enough to work with some very smart nuclear physicists in University of Rochester, and the collaboration goes in the same way. And on the other leg, like for a person like you who have deep insight on the system aspect of data centers, I learn a lot from people like you, and then we can combine some of these forces to bring in real changes, because AI by itself is dry, but when you combine the AI with the domains, just like you combine cheese with the burgers and the bun, it tastes much better.
Nice. So adding spice to AI is one of your roles and responsibilities. I like that.
And to scale.
It's very memorable.
Because we are all very insignificant individuals. When we scale it up as teams and bigger teams, bigger collaborators, that's where the magic starts happening.
Plus you have digital twin for each one of them. The scale goes through the roof.
I wish.
Now, coming back to digital twins for data centers, why? Why did you start? Why did others start? Why are they important?
Yeah. Just like as I was explaining, what worries me is the responsible and trustworthy AI. And also what worries me is with this tremendous technology, what is happening is the amount of computation is growing. I don't know what is the term. It's not even exponential. It's more than that, right? And now with this huge amount of computation comes a tremendous, I'd say, consumption of energy. Now data centers are increasingly consuming bigger and bigger part of this and the total energy that is produced. And Hewlett-Packard Enterprise is the leader of supercomputing. So I think we have in us the responsibility to make sure that a few things about sustainability. Firstly, we are using energy in the most efficient way, and then we are also using the resources in the most efficient way. So this is a dual play. On one side, we want to reduce the energy, reduce the carbon footprint, but on the other side, we want to also reduce the e-wastes in the sense that we want to pack maximum computation within a limited amount of hardware. And both this optimization and the energy and sustainability equations can be solved by digital twins. And that's what makes me very excited.
So I'm playing a little bit of devil's advocate.
Yeah.
We used to have dashboards for I don't know how many decades. Since the first computer, there was a dashboard for load, for whatever. How are digital twins better than dashboards? I understand they have more active role, they're smarter and all of that, but can you succinctly describe this difference for those newcomers?
Yeah, so I think it's a common misperception that the digital twin is all about visualization and dashboard. And of course, in any technology, you climb levels, level 1, level 2, level 3, level 4. Now, the way I see it is, on the level 1, you have the simulations. You can simulate a system. On the level 2, you're monitoring the system, and you are doing some cool visualizations. But that's the surface. Now, at Hewlett-Packard Labs, what we try to do is we try to extend the technology frontier beyond what is there, right? And then as you climb to level 3, now you are not only monitoring the different matrix from a real system, but you are trying to apply AI in forecasting, in trying to predict some anomalies, etc. And in level 4, you are bringing in very cool technology like reinforcement learning, which goes after the self-autonomous driving to then control the system. And just to give you one analogy, a long time back when I was an intern in Dunlop, of all places, they had this huge industrial setup for steel cord belts, which you see in airports as you go, right? So now we used to have PLCs to control small individual components in this huge system. And then soon we realized that we need collection of those things to understand the system better. And then computers were introduced to connect a few of those PLCs. But even then, our vision was very myopic. Our observability was very myopic. So now you need to add all these things together into a digital twin of the entire system and connect it to the real states of your actual physical system. And then you come to a situation where you can actually have more informed way of controlling these data centers, for instance, right? And then that is also a platform for you to bring in machine learning in this digital twin to package machine learning well enough in this context to leverage it.
So what are the hardest challenges as you climb up this level? Is it to climb faster, more reliable, more intuitively? What are your challenges?
One of the biggest challenges, like so far, there are two things, right? You can always optimize specific aspects of the system, like cooling. There have been some machine learning work on cooling. But what if you can holistically optimize data centers? There are so much things, right? Even if you consider just the energy and sustainability consumption, you can shift loads around, based on when it is, when the carbon intensity is low or when the temperature is low. And then you can also have energy storage. So now you see, even in this simple situation, you have three different elements to control. Now, in that holistic control, till now, the technology is stuck in static optimizations. The question is, can we bring in dynamic? Can we bring in a controller which can work in real time with the dynamics of the system? Just to give you an analogy, you do some static optimization and ask a driving agent to drive a car at a specific gear in a highway. Now, the weather in the highway may change. It may rain, it may shine. So, so now you have to shift gears. Now, the congestion in the road can be very different. So now you are in a situation where you need to reroute yourself through different roads. And that's where some of the very smart technology like reinforcement learning behind autonomous driving comes in to steer your data center in different directions dynamically based on changing situations. And moreover, we have got multi-agent reinforcement learning. That's where now you can control multiple aspects in this holistic optimization so that you can achieve the goals. And to go a little bit deeper, all these things have interdependencies. For instance, the load shift agent can shift loads based on carbon intensity, but weather also is important. Now, the battery agent is an energy hedging mechanism by which you store energy when the cost is low and you source energy when the cost is high. But there is an interdependency between them. Now, how do you resolve these interdependencies? So those are some of the challenges which machine learning with reinforcement learning solves.
So you describe very well, and I especially like your analogies, how digital twins are applied to data centers. Could they be applied to other areas like consumer space, etc.?
Yeah, absolutely. So, if you think, when Bell Labs, our modem business was almost gone, and then came 56 kbps modems, and then it was reincarnated, we went in to capture 50% of the world market, and Hewlett-Packard was a big customer for us. How we make that happen is not only with smart algorithms, Bell Labs was known for that, but we actually sort of built a digital twin of the modem. So we have our simulator which can simulate all the modem functionalities, and then any customer throughout the world, and there were more than 100 million customers using modems, we can just collect the logs and we can replay it exactly in the same way what it was in his system. So that was the secret recipe for us to cover 50% of the world market. Now, that problem was simple. But again, I want to come back to the digital twin for the data center because there is another key message over there. we are not only solving it for individual data centers, but we are having a local global play where we are now using this car analogy and going for a fleet. And in the fleet, a human operator can manage a fleet. Now you are extending this technology across the data centers globally, but you can have a smarter person than a human in the form of, again, hierarchical reinforcement learning, where we manage the loads across the globe and we bring in this same homogeneous technology in a hierarchical fashion to cover all of the data centers for a given enterprise.
So once you are completely done, covered your fleets, individuals, etc., how will you measure your success?
That is a great point. So I think, the way I set my goals is what is the actual difference that some of this technology that Hewlett Packard Enterprise is making, what is actual effect? So the way I measure it is, say for a deployed system, how much is a net reduction of carbon footprint? How much is a net reduction of energy? And you can also carry it over to pricing. But beyond that, there is something more. These are all metrics, but everything in the world is not matrix. I also try to see, from the different climate models, etc., how much are we polluting our earth? So how much are we reducing, these pollutants and making room so that in future when the cleaner energy comes in, we still have a big part of the earth intact. Now, on the business side, what we have seen is that this is a very good messaging, but our customers also want to have more bang for the bucks. Mm-hmm. So that's where the second part of the digital twin comes in optimizing compute within the data center so that the customers can do more for less.
Thank you. Very nice. In the beginning, you mentioned that you're working with many other people. Can you describe this ecosystem?
Yeah. So, so this ecosystem expands to academia, to some of our customers who may actually treat them as collaborators, because customers are co-collaborators, because we are trying to solve similar problems which help them and which help us. Now, one of the ecosystem that we are working with is called the Exadigit Consortium. It was led by Oak Ridge National Labs, who is our customer, but many of our supercomputing customers are within that Exadigit Consortium. And what we are trying to do is, many of them are now trying to build digital twins. And because of some of the advances that we have made with digital twins and bringing in AI, we are helping them achieve their goals. So that is one example where the collaboration happens. But there are many parallel collaborations. Like, we are contributors to some of the top machine learning conferences like NeurIPS and AAAI and CVPR. So there we have our research community with whom we vigorously engage. But beyond that, we also here at Packard Labs have always funded many academic research. So, like San Jose State, etc. We also have these academic partners with whom we are doing collaboration.
Does your team open source things, and do you believe there's opportunity for standards in AI digital twins?
That is a great question. I'm a strong believer of open source because the open source kind of makes the technology get vetted by a huge community of technologists. And this community engagement, firstly, it helps you mature the technology much faster, but also the adoption of the technology, the oversight that it brings in, and that eventually pushes more standards. So in a way, when you open the technology and share it with people, just like, if I'm thinking by myself, I cannot go too far. If I'm explaining to others and have them brainstorm, question me, I'll be a lot stronger. So that's how I feel the open source movement is a great one. And then the second part, as you told about standards, I'm a strong believer of standards because when we follow certain standards, there are several advantages. Our technology then become readily portable or readily integrable in many other systems. And because there are standards and because there are guidelines, we are honest to ourselves, bring in all the requirements that makes technology a product. And that's again one of the reasons why even Hewlett Packard Enterprise and me personally, we are part of the National Institute of Standards and Technology. We contribute to the AI Safety Consortium because that's how we form standards and guidelines and have compatibilities and have checks and balances.
You're working on extremely interesting topics. What do you find most gratifying in your career?
Part of us always think, what do we do in our lifetime, which leaves some goodness in the world, right? So I'd say that if you look beyond AI and everything, right, what difference do we make to the world? And one of my most gratifying experience in Hewlett Packard Labs is we get to do so much of good work, from the sustainability of data center, which is becoming a polluter, but also nuclear fusion, where we bring in the clean energy, wave energy converters in a similar way, and also the trustworthiness of AI. Because what I find, Hewlett Packard Enterprise always has been a very responsible player in this industry, and that's the thing where I thrive in, the opportunity to do some global good.
If you would start your career today again, would you do the same way, or what would you do differently? And presumably this is also a message for our early career path colleagues.
Yeah. So, we all have our own vulnerabilities. So when I started my career in speech recognition, the AI winter started. I chickened out. I went to industry where I enjoyed learning different parts of the engineering, but maybe I should follow my passion and had my path, more steady path in AI all this time. And that's where we sometimes miss the insights. So what I would like to tell to the early career technologist is follow your passion, follow your heart. You are going to find success. The second thing which I would also like to point out is there's nothing called missed opportunity. We create our destiny. We create our opportunities. And in today's world, there are so many ways to learn because, see, knowledge is power. And even in my mid-40s, I went back, did a bunch of courses at Berkeley, and then nearing 50, I did a bunch of courses in Stanford. And so it's a lifelong process of learning. And for all younger technologists, I'd say follow your passion, keep updating yourself, and you will reach.
These are outstanding advices, not just for early career, but everyone. We usually end this podcast on a personal note. Tell us a little bit about you. What is the latest book you read? What do you do in your spare time? How do you see this environment compared to where you lived earlier?
So let me also make a social message because I think social awareness is very important. So I am dyslexic, and there should not be any stigma about that. Our brain processes different stuff in a different way. So because I was dyslexic, I always find challenging to read. But you know what has changed from the time when I was a kid is the dissemination of knowledge is happening in so many different ways. So one of the things that I do on a regular basis is just go to YouTube. There are so many fascinating lectures coming from different conferences, coming from academia. So those are the books for me because I find and then I read a lot of research papers out of NeurIPS, out of III, and out of ICML. So that's when I reflect on what I learned from all those lectures and then think deeply to understand and gain insights.
Hey, thank you very much. Always pleasure talking to you and learning every time.
It was a pleasure.